So as you promised me, I will be taking the test in the, uh, I mean, on this coming Tuesday, right? The test will be based on decision theory.
Ma'am, probability inequalities.
Oh, sorry, probability inequalities. Thank you for reminding. Yes, probability inequalities. Decision theory we have already done. Also, you have submitted decision theory assignment also. Now there will be a test, and in the same week I will post the assignment related to. So what I was thinking is I will take a test of say 10 marks on probabilities inequalities, and then assignment will be only of so rather it will be better if I don't take I will decide, because on order statistics I will give you what you can say assignment of remaining 10 marks. So better there will be no assignment based on unit 2, that is probability inequalities, only tests will be there, and on order statistics I will give you one assignment, and test will be of say 5 to 7 marks. Probability inequality tests probability inequalities test will be of 7 marks around, and then remaining 8 marks test will be based on order statistics, and then uh, remaining assignment of 10 marks will be also based on order statistics. Is it clear? Yeah. So let's go to the next what you can say example, which is based on order statistics. Again, the theme is same. Just I will explain the example and we'll go to the next theorem. Let y1 to y4 be four order statistics from a random sample of for a random sample of size 4 from the population whose density function is fx is equal to 2x. We have to find probability that y3 is greater than or equal to half. Again, the example is of the same type what we did in the last lecture. There we considered the order statistics probabilities corresponding to order statistics y1 and y4, and now I'm finding out probability corresponding to y3. So remember that whichever variable is there, like here it is y3, you need to obtain the distribution of y3 first, and then only you can find out the probabilities. So the solution will be like this. The PDF which is given to you is fx is equal to 2x. Now to find the PDF of any order statistics, first we have to find out the capital Fx, that is cumulative distribution function of fx, and which will be integral from 0 to x fx dx. And if you solve it, I have already solved it in the last lecture. So directly I have mentioned it over here that capital Fx will be, since it is integral 0 to x fx dx, it will be x square in this case, right? Now, we know that the PDF of rth order statistics is given by this. So do it by heart now. G of yr is equal to n factorial capital F of yr raised to r minus 1 upon r minus 1 factorial 1 minus f of yr raised to n minus r upon n minus r factorial into small f of yr. Right? So what I need to substitute is what is capital F, what is small f, and then in place of x, we will be replacing it by yr. But now what is my r in this case? I need the distribution of y3. Hence, I'm finding g of y3. So put r is equal to 3. N, that is sample size. Sample of size 4 is obtained. So n is 4. So if I put r is equal to 3 and n is equal to 4 in the formula of g of y bar, it will be like this, right? Now what is my capital F of y3? What is capital Fx? Capital Fx is x square. So what will be capital F of y3? Just you replace x by y3. So that will be y3 square. So see here, capital F of y3 is y3 square raised to 3 minus 1 as it is upon 3 minus 1 factorial into 1 minus f of capital Y3 is, capital F of Y3 is 1 minus Y3 square raised to 4 minus 3 upon 4 minus 3 factorial into what is small f of Y3? Small f of x is 2x. So small f of Y3 will be 2y3. This Y3 should be smaller in the density. Okay. So what density I got for Y3? Density of Y3, that is PDF of Y3 is given by, if you solve it, you will be getting it as 24 into Y3 raised to 5 into 1 minus Y3 square. Remember that Y3 will lie between 0 to 1 because Xi's are lying between 0 and 1, and Yi's are nothing but ordered Xi's, right? So they will not go out of range. Okay, so Y3, remember always whenever you are writing PDF density, you must specify the range of the variable, that is 0 to 1 over here, and is equal to 0 otherwise also. Okay, now which probability I am finding? Probability of Y3 is greater than or equal to half. Since Y3 is lying between 0 and 1, that will be nothing but integral from half to 1, because Y3 is greater than or equal to half. So lower range is half. Till what I can integrate? Till 1 it is only taking value. So till integral from half to 1 gy3 dy3, right? And now what is gy3? Gy3 is this much. And then our usual integration process. Hope you will be able to do it. Hence, I have only given the answer over here. What is the integration of y3 raised to 5? It is y3 raised to 6 upon 6 minus integration of y3 raised to 7, y3 raised to 8 upon 8. Put these values and find out the answer. It is coming like this. Okay, I don't think there is any problem in execution of this. So let me go for the next derivation. Derivation of what? Joint PDF of rth and or th order statistic. So we obtained already PDF of rth order statistic, that is G of YR. But I want to obtain now, sorry, joint PDF of two order statistics, suppose YR and YS. It can be anything. Your R and S can be anything. So if I want to find joint PDF of Y1 and Y2, you just put R is equal to 1, S is equal to 2. Y3 and Y10, you just put R is equal to 3 and S is equal to 10. Just R should be less than S. That's it. Okay, now what is the expression for this joint PDF of YR and YS, Rth and Sth order statistics, that we are going to obtain now? Okay, so G of YR comma YS is equal to G dash, capital G dash of YR comma YS. That means nothing but derivative of capital G of YR comma YS with respect to YR and YS. That is dou square of dou YR dou YS of capital G, right? Now, if you remember what we did in the rth order statistics by second method, same method I am going to follow over here. That is, I will be using the definition of derivative in terms of limit, right? We know what is f dash of x, limit h tends to 0, f of x plus h minus f of x upon h, isn't it? Same way I'm applying it over here. So since now there are two variables involved, now I'm taking limit with respect to h tends to 0, k tends to 0, g of yr plus h, ys plus k minus g of yr comma ys upon, oh, oh sorry, here it should be h. Why I wrote s, I don't know. Right? Limit with respect to limit, I am taking the variables. Okay. So now we have seen last time also this concept f of a minus, what is capital F of a minus capital F of b? It is nothing but probability that x lies between a and b. The concept I explained in the last lecture. Same concept I am applying it over here. Capital G of YR plus H minus capital G of YR, what it will be? Probability that variable YR will lie between YR to YR plus H. Similarly, g of ys plus k minus g of ys will be probability that variable ys will lie between ys to ys plus k, right? Same concept what we used in the earlier, what you can say, derivation of rth order statistics by the second method. Only the difference is that here two variables are involved, that is yr and ys. Hence limit will be with respect to two variables, that is I am taking here it as h and k. Now I want to find this probability in the numerator. Okay. Now to find that numerator probability, you consider the following arrangement. What is that? In which probability I am interested? I am interested in finding probability of rth order statistic will lie between two numbers. The numbers are yr and yr plus h, and probability of sth order statistic lies in between two numbers, that is ys and ys plus k. Same I have explained it with the help of diagram. Suppose this is your number line, real line, that is from minus infinity to plus infinity. Okay. Now, what do we want? Rth order statistic lies in between two numbers yr to yr plus h. And sth order statistics lies in between two numbers ys to ys plus k. Okay. Now, try to understand this. Rth order statistic will lie between two numbers is same as corresponding to rth order statistic. There will be any one of the xi's, because yi's are nothing but ordered xi's. So x1 to xn may say any one xi will corresponding to yr, right? So what I would like to say is corresponding to YR, there will be one of the XI. So in general, what I want, rth order statistics should lie between these two numbers is same as that corresponding XI will lie between YR and YR plus H. Right? Now, same way over here also. Ys will lie in between ys to ys plus k is same as corresponding to ys. There will be one of xi's, and I want that xi should lie between ys and ys plus k. Isn't it? Now, we want rth order statistic should lie in between this, right? So below rth order statistic, how many order statistic will be there? R minus 1. And corresponding to those r minus 1 order statistics, there will be r minus 1 xis, isn't it? So how those xis should be? They should lie below this yr, isn't it? Similarly, s order statistic is lying in this interval, and rth order statistic is lying in this interval. Right? Okay, let me show it with the help of Jamboard. That will be better, I think, because here I cannot use the pen. Oh, what is happening? It is asking for permission to share the Jamboard with me, but you are not required to join it. Just if you want to contribute while writing, you can join, otherwise not. But I don't think your contribution is required over here. See, the same concept we have did for rth order statistics. Now we are doing it for rth and sth order statistics. Okay. So we are considering, oh, bear with my drawing. We are considering a real line from minus infinity to infinity. What I want the probability that rth order statistic should lie between a very small interval of length h, that is between yr to yr plus h. Who should lie over here? Capital YR. That is, what is the probability that the order statistics YR, rth order statistics, takes value between YR to YR plus H. Similarly, suppose here somewhere YS is there. Small ys means some number, okay, some value. And here it is ys plus k, where ys to ys plus k is basically a very small interval of length k such that k is tending towards 0. मतलब k बहुत small होता जाएगा, right? Here it is ys. So basically we are interested in finding the probabilities that rth order statistics and sth order statistics, they will lie within these two intervals. Now, as I told you, corresponding to YR, there will be one of excites. Why I'm interested in one of xi, how many xi's? Because I know the distribution of xi's, and from that I want to obtain the distributions corresponding to yi's. So definitely I have to convert it in the form of whichever I know, right? So even though I am finding the probabilities corresponding to yi's, I am converting them in terms of xi's because I know the distribution of xi's, right? Okay. So corresponding to rth order statistic YR, there will be any one of the xi's. Similarly, corresponding to sth order statistics, there will be any one of the xi's. Now, we want that rth order statistics should lie within this interval. Now, yi's are ordered, right? So rth, if it is lying in this interval, then where will be the r minus 1 of the yi's? They will be definitely below the small yr, isn't it? And corresponding to those r minus 1 yi's, there will be how many xi's? R minus 1 xi's, right? Corresponding to r, okay, let me tell you once again. Here we want capital YR, that is rth order statistic should lie, right? So where will be Y1, Y2, YR minus 1? First R minus 1 order statistics, they will lie below this. Why below this? Why not one of them over here? Because basically this H is a very small interval of, H is a very small interval which is tending towards 0. So only YR can lie between that. Okay, so where will be y1, y2, yr minus 1? They will lie to this side, right? Now corresponding to those y1, y2, yr minus 1, there will be r minus 1 xi's. Need not be x1, x2, xr minus 1. कोई भी हो सकते हैं because they are not ordered, right? Now, if rth is lying over here, r minus 1, definitely r minus 1 यहाँ पे होंगे, right? S is lying over here, तो यहाँ पे कितने yi's होंगे? Between yr plus h to ys plus k, ये वाले इंटरवल में how many yi's will be there? यहाँ पे s थे, यहाँ तक r हो गए थे, तो यहाँ पे बीच में कितने होंगे? s थे यहाँ पे आने वाला है, तो इसके पहले टोटल कितने होने चाहिए? s माइनस 1, उसमें से यहां तक ऑलरेडी r हो गए हैं, तो ये पर्टिकुलर इंटरवल में कितने yi's होंगे? s माइनस 1 माइनस r, सो आई विल राइट इट एज s माइनस r माइनस 1. ट्राई टू अंडरस्टैंड दिस. यहाँ पे एस ऑर्डर स्टैटिस्टिक्स है, यहाँ तक ऑलरेडी आर हो गए हैं, तो वाईएस के पहले टोटल कितने होंगे ऑर्डर स्टैटिस्टिक्स? एस माइनस 1, क्योंकि यहाँ पे एस थे. उसमें से ये इंटरवल तक वाई आर तक ऑलरेडी आर हो गए हैं, राइट? सो एस माइनस वन माइनस आर will lie within this interval, isn't it? So I am writing it as S minus R minus 1. Actually, it is S minus 1 minus R, right? Because again, I am telling you कि यहाँ पे S third statistics is lying means below YS total S minus 1 order statistics will be there. Minus already R यहाँ तक हो गए and I want how many will lie in this interval. So S minus 1 minus R and I am writing it as S minus R minus 1. So within this interval S minus R minus 1 order statistics will lie and corresponding to those S minus R minus 1 order statistics there will be those many exercise, right? Those many means S minus R minus 1 of exercise. Isn't it? Now, you see, sample of size n is there. Out of which यहाँ तक कितने डिस्ट्रीब्यूट हो गए? जो टोटल एक्सरसाइज है वो कितने इंटरवल में डिस्ट्रीब्यूट हो रहे हैं? एक इंटरवल टिल वाई आर, दूसरा इंटरवल वाई आर टू वाई आर प्लस एच, तीसरा इंटरवल वाई आर प्लस एच टू वाई एस, चौथा इंटरवल वाई एस टू वाई एस प्लस के, और अभी पांचवा इंटरवल वाई एस प्लस के टू इंफिनिटी. अभी उसमें कितने वाई आईज रह गए हैं? यहाँ तक टोटल एस हो गए, राइट? टोटल है कितने? एन. उसमें से एस यहाँ तक डिस्ट्रीब्यूट हो गए. अब रिमेनिंग आर हाउ मेनी? एन माइनस एस, राइट? So same I have written it over there. Where? So corresponding to these n minus s yi's, there will be n minus 1 s xi's. So let me show it. See, one xi should lie within this interval, one should lie within this interval, r minus xi's will be before this, s minus r minus 1 of xi's will be in between this interval, and remaining n minus s of the xi's will be over here. Isn't it? Now, again, which is this situation? This is a multinomial situation. I explained you last time trinomial situation, which is expansion of binomial. And again, multinomial is its expansion. So what are we considering in binomial? In binomial, result of each trial is divided into two mutually exclusive outcomes, either success or failure, right? There are n trials. Probability of success is same throughout, right? Now, what is multinomial situation? Result of each trial is divided into more than, you can say, 3 possible mutually exclusive outcomes. क्योंकि trinomial में 3 possible होते हैं, binomial में 2. So if it is more than 2, more than 3, it is a multinomial situation. Okay. So what is here? What is experiment basically? Each xi will lie in one of the 5 interval, that is interval till this, or between this, or between this, or between this, or more than this. Are you getting? Interval, first interval is till yr. Oh, इस shapes पे highlightener चलता नहीं है शायद. First interval is till YR. Second interval is YR to YR plus H. Third interval is YR plus H to YS. Fourth interval is YS to YS plus K. And fifth interval is YS plus K to infinity. So we will take first sample. It will lie within one of the five intervals. Second sample, it will lie, sample means second observation. It will lie in one of the five intervals. So result of each trial. What is my trial in this case? Each observation where it will lie. It will lie in one of the five intervals, right? So it is a multinomial situation. Sample of size n has been taken. And what is the probability of success over here? Here it is not like success and failure because there are five different intervals. So here basically P1 is the probability that observation will lie within the first interval. P2 will be the probability that observation will lie in the second interval. Similarly P3, P4, P5. Okay, so I will obtain those probabilities now. Now consider the first interval. What is the first interval? First interval is observations will lie below YR. So what is the probability that Xi will be less than value YR? Okay, how many observations are there? R minus 1 of Xi, they are lying less than YR interval may. Okay, so what is the first probability? Probability of Xi to be less than YR. Can I write it as capital F of YR? I can, right? Now, which is the second interval? Second interval is Xi will lie between YR to YR plus H. How many observations will lie in that interval? 1. What is the probability that Xi will lie in between YR to YR plus H? I can write it in terms of capital F, isn't it? It is capital F of A minus capital F of B. That is capital F of YR plus H minus capital F of YR. Now, what is the third interval? Xi will lie in between YR plus H to YS, right? How many observations will lie in this interval? S minus R minus 1. What is the probability? Again, I will write it in terms of capital F. Capital F of YS minus capital F of YR plus H. Now, next interval is YS to YS plus K. YS to YS plus K. How many observations? Only one observation. What is the probability? Again, F of B minus F of A. That is F of YS plus K minus F of YS. Now, what is the last interval? Observation will lie beyond the YS plus K, right? So, probability, oh, why it is disturbed? Okay, okay, it is not disturbed. So, last interval will be Xi will lie beyond the YS plus K, right? And how many observations will lie there? N minus S. What is the probability of lying Xi beyond YS plus K? I can write it as 1 minus capital F, isn't it? Okay. So now I will use the multinomial PMF and I will write the expression, this probability, which this. Because of all this description, I came to know that it that probability I can write it by using multinomial situation. तो मल्टीनोमियल का पीएमएफ क्या होता है? इफ यू रिमेंबर मैंने ट्राइनोमियल का बताया था आपको. ट्राइनोमियल का क्या होता है? एन फैक्टोरियल अपॉन एक्स फैक्टोरियल इंटू वाई फैक्टोरियल इंटू एन माइनस एक्स माइनस वाई फैक्टोरियल into p1 raised to x, p2 raised to y, 1 minus p1 minus p2 raised to n minus x minus y. You will be having it now in Namrata madam's paper. She might start with trinomial or it may have started also. So at that time you will come to know it more clearly. Okay, तो basically क्या करना होता है? What is n? N is the total number of trials which are here n only, n observations है ना. So n factorial. Now हर इंटरवल में कितने कितने लाए हो रहे उतने फैक्टोरियल. सो फर्स्ट इंटरवल में R1 में R minus 1 फैक्टोरियल, सेकेंड इंटरवल में ओनली 1, थर्ड में S minus R minus 1, फोर्थ में 1 एंड फिफ्थ में N minus S. So those many factorials, right? Now corresponding probabilities raised to जितने भी observations थे. Like first probability कितनी थी? f of yr raised to r minus 1. Second probability, this much, raised to 1. Third probability, this much, raised to s minus r minus 1. Fourth probability, this much, raised to 1. Fifth probability, this much, 1 minus f of ys plus k raised to n minus s. Okay, so same thing has been written over here, but because of that equation editor problem, I cannot adjust the terms. क्योंकि मैं adjust करने गई ये नीचे लेने गई, so it is disturbing a lot. So I thought let's keep it over here on, as it is. But you will understand definitely, I'm sure. Okay. Now what I did in the next step, I have taken the limit inside. Okay. So 1 upon hk as it is, n factorial, that constant term as it is, just I removed 1 factorial because anyway it is 1. Now in the first term, f of yr raised to r minus 1, there is no term containing h. So I have not taken. So it is constant with respect to limit. So written as it is. In the second term, there is h, so I wrote limit h tends to 0, f of yr plus h minus f of yr. Whatever is here, just I am writing it with the help of limits only. In the third term, if h is there, so again limit h, I need to take the limit with respect to h tends to 0, f of y minus f of yr plus h raised to s minus r minus n. So basically what I did, I took the limits inside. Next, limit k tends to 0, k tends to 0. Wherever h is there, I will take limit with respect to h tends to 0. Wherever k is there, I will take limit k tends to 0. What I will request is you go through these notes today only and try to write the derivation by understanding it from here. Then only you will be able to understand it. Just notes में है, exam के time पढ़ेंगे. Don't do like that. ओके और एग्जाम के पहले वाले दिन हम लोगों को व्हाट्सएप करके फिर डाउट पूछने, दैट इज नॉट गुड. ओके राइट. सो नेक्स्ट स्टेप इज just I will take the limit, that's it. Okay, where I was in this state or in this. Okay, so what I will do is I will just rearrange the terms. So this n factorial, I wrote it over here. See, this n factorial. Okay, why it is not highlighting, I don't know. N factorial, I wrote it as it is over here, n factorial. Okay, anyway, I will be highlighting n factorial as it is. F of yr raised to r minus 1 from here upon r minus 1 factorial. So f of yr raised to r minus 1 upon r minus 1 factorial. Now, what will happen with this if I take the limit h tends to 0? Okay, I will come to that term afterwards. Let me finish with the remaining terms. See, limit h tends to 0, f of ys minus f of yr plus h tends to 0. What will happen to this? Only f of yr will remain. Oh, by mistake, I wrote it over here. Right? When h tends to 0, what will happen to this? Since this h is tending towards 0, only yr will remain over here. So limit h tends to 0. Since this h is going towards 0, what will remain is f of ys minus f of yr raised to s minus r minus 1 upon this s minus r minus 1 factorial. I am writing it over here, s minus r minus 1 factorial. Now one more term, which 1 minus f of ys plus k, limit k tends to 0. Since this k is tending towards 0, what will remain is 1 minus f of ys raised to n minus s upon this term of n minus s factorial. So same thing, I wrote it over here. Okay, now two terms are remaining. Which two terms? These two terms. one term from here. Limit h tends to 0, f of yr plus h minus f of yr. I will adjust that h over here. So what is the definition of derivative in terms of limit? Limit h tends to 0, f of x plus h minus f of x upon h. Same thing is here. Limit h tends to 0, f of yr plus h minus f of yr upon h. This I will adjust upon over here. Right? And so what I can write for this? F dash of yr. And that is nothing but small f of yr, which I'm writing over here. Are you getting? Same case with this term also. Limit k tends to 0, f of ys plus k upon minus f of ys upon k. Isn't it? And what it will be? F dash of ys, which is nothing but small f of ys. Right? So this is the expression for joint PDF of rth and sth order statistics. Okay. Is it clear? Yeah, there is any doubt. Please let me know. So what I need to find, समझो तुम्हें एक sample दिया है from a particular population whose PDF is known to you, whose distribution function you can obtain. Then can you obtain the joint distribution of rth and sth order statistics? Yes. Just what do you require to know? Small fx, capital Fx. Small fx पता होगा, so you can always obtain capital Fx. Right? And you can write the expression for rather you can obtain the joint PDF of rth and sth order statistics. Hope this is clear to you. Is there any doubt? Please ask me. I am ready to explain it again. Any doubt? People are leaving. I don't know why this is so. Anyway, okay. So if you don't have any doubt, I will stop here because the expressions are a lot of derivations are there and difficult for me to cover within 5 minutes. So we'll stop here.